Did you catch what DeepMind just did? They didn't just improve robots. They rewired how AI thinks inside them. We're talking about robots that don't need the cloud, don't need Wi-Fi, and don't need to call home to understand, see, and act in the real world. It's called Gemini Robotics On-Device. And honestly, this might be the biggest leap toward truly autonomous machines we've seen all year. Today, we're breaking down what it is, how it works, and why every robotics company and every engineer working in edge AI should be paying very close attention. Let's dive in. So here's the traditional setup. Most robots you've seen, whether it's a warehouse bot, a home assistant, or even a prototype humanoid, they rely on the cloud for the real heavy lifting. Computer vision? Offloaded. Command parsing? Sent to a server. Decision-making logic? Yep, hosted somewhere else. Why? Because foundational models are just too big, too slow to run locally. Until now. What DeepMind just dropped is a full vision language actions VLA model that can run entirely on a robot's own hardware. That means real-time understanding of what it sees, what it's told, and how it should act, all without sending a single byte to the cloud. And yes, it still uses Gemini's multimodal capabilities, just shrunk dramatically. This is where things get exciting. Gemini Robotics On-Device is a compressed transformer architecture, essentially a mini version of the big Gemini models that powers things like image captioning, reasoning, and language understanding. But this one? It's been slimmed down, quantized, and optimized to run directly on edge accelerators like NVIDIA Jetson, Coral TPUs, or even ARM-based inference chips. Now, what does that mean in practice? It means the robot doesn't just hear, "Can you fold that towel and zip the bag?" and freeze. It actually understands the visual scene, recognizes what a towel is, identifies where the bag is, tracks the zipper, predicts grasp points, and executes each step in sequence. In one demo, the robot is handed a completely unfamiliar object. No prior data, no specific training. It identifies it, infers its function, and completes the task anyway. Why? Because it's not memorizing commands. It's reasoning with context, like a human would. One of the most mind-blowing things about this? It does all of that offline. We're not just talking about low latency here. We're talking complete autonomy from cloud infrastructure. Think about what that unlocks. Search and rescue robots that operate in disaster zones with no signal. Home robots that don't leak your data to third-party servers. Industrial machines that keep running even when the network's down. And the kicker? There's no degradation in core functionality. You still get the same smart, multimodal behavior, vision, language, action, but localized. This isn't just about speed, it's about sovereignty. Edge AI is becoming real AI. Now, here's where DeepMind went next level. Instead of requiring thousands of training samples per task like older models, Gemini Robotics On-Device fine-tunes using just 50 to 100 demonstrations. That's thanks to some seriously advanced attention mechanisms and dynamic memory compression. So say you want the robot to learn how to pour dressing on a salad, you demo it a few times. It doesn't just mimic, you can change the bottle, the angle, even the plate layout, and it still performs flawlessly. It's generalizing, not just following steps. And that's crucial because if we ever want general-purpose robots in our homes or factories, they must be able to learn from example, not just code. Let's talk about the real demos. The robot received the command, zip the lunch bag, pour the dressing, then fold the napkin. Now remember, these objects weren't custom tagged or specially labeled. The model had to visually interpret them, generate action sequences, and execute all that with zero external support. That's a full multimodal loop. Perception, language comprehension, planning, control, all on device. Another scenario: the robot picked up a towel, soft, deformable, never seen before, and executed a multi-step fold sequence. No custom grasp planning, no LLM handoffs, no physics engine tricks, just real, grounded AI behavior. So, why is this such a big deal? Because it marks a turning point for embodied intelligence. Until now, robotics has always had this trade-off. You either get high performance via cloud AI and lose reliability, or you go local and give up generalization. DeepMind just showed you can have both. This isn't just incremental improvement. This is the start of truly autonomous agents, ones that don't need you to hold their hand, script their actions, or hard code the environment. It pushes us closer to what researchers call open-world robotics. Robots that can function in messy human environments, not just clean factory lines or lab demos. And for developers, DeepMind's providing a full SDK for adaptation, meaning startups can build on top of this, right now. Here's where I want to zoom out. Gemini Robotics On-Device isn't just a clever model, it's a paradigm shift. We're looking at the foundation of offline home assistants that don't eavesdrop, factory robots that reconfigure workflows without reprogramming, and mobile robots that can operate on the Moon or Mars. The next decade of robotics won't be about bipedal form factors or humanoid aesthetics. It'll be about who can run truly intelligent behavior without cloud crutches. DeepMind just pulled ahead in that race. Now, if you're wondering, how does this compare to what's out there? Well, most models running on-device today are either narrow, think robotic arms with a fixed grasp policy, or they still require pipelining multiple models for perception, NLP, and action. Gemini On-Device does it all in one stack. Vision and language inform action directly, thanks to a shared latent space across modalities. That's why the generalization is better, that's why the latency is lower, and that's why it feels more intelligent. We're not there yet, but we're closer than ever. So, what does this mean for us, engineers, creators, future users? It means we're about to enter an age where robots can think locally, adapt fast, and actually live with us. Not as fragile machines that need constant babysitting, but as reliable, intelligent systems. And the tech is finally catching up. This isn't a teaser from some research paper that'll take 5 years to productize. It's already in. Now I want to hear from you. What would you build with a robot that could think on its own? Would you put it in a kitchen, a hospital, your studio? Let me know in the comments. And if you want more deep dives like this into the bleeding edge of AI and robotics, make sure you hit that subscribe button, because this is just the beginning. See you in the next one.